Recall that the domain is the set of x values to be evaluated by a function, and also recall that the range is the set of y values that actually result from the evaluation of the function. And then there is another type of a definition called the codomain, which is the set of all y values that could be possibly result from the evaluation of the function. The codomain of a function is always assumed to be all real numbers unless otherwise stated. So what we're going to spend some time here is looking at domains, codomains, and ranges of some graphed functions. So part A, it says identify the domain, range, and codomain of the graph. So we look at all three of these graphs. They are all the exact same arch-shaped graph. The first one, we're trying to figure out what are the possible x values of this function. So the x values you can see is highlighted there in orange as the x-axis. And notice how the graph, as it continues to get lower and lower and lower, both directions, it keeps getting wider. So it is slowly moving to the right. You can see how it's slowly moving to the right as it continues this path, and it's slowly moving to the left as it goes down this path. So since it is slowly moving to the right and slowly moving to the left, what that means is it's actually going to touch all the numbers in existence. So it touches really, really, really big numbers and really, really, really small numbers. And since it touches all the numbers in existence, it means it's also touching all the fractions and decimals in existence as well. So if it touches all the numbers that can possibly exist, a common way to describe the domain is using the phrase all real numbers. Not just all numbers, all real numbers. You do have to say real numbers because, yes, believe it or not, there are certain numbers called imaginary numbers that we will talk about later in this class. But right now, all you need to remember is that if it touches all numbers in existence, including all the fractions and all the decimals and really big numbers and really small numbers, then the domain is all real numbers. The range is all the possible y values in existence. So the y-axis is highlighted by a green line there in the center of that arch shape. And notice that this graph is getting really, really low, really, really fast. It just keeps getting lower and lower and lower. But unlike the first one, it's not going the opposite way as well. It's not going higher and higher and higher. As a matter of fact, it gets to the origin point right here that I've highlighted, and then it turns right back around and goes back the other direction. So it does go all the way down to the lowest number that you can actually think of and then lower than that, but the highest number it could possibly be is 0. So because the maximum y value is 0, we would state that the range is y is, if you recall this symbol, when you underline that arrow pointing to the left, that is the less than or equal to symbol. And since the entire graph is below 0, we would say that the range of this graph is y is less than or equal to 0. And then lastly, to figure out the codomain, remember codomain is all real numbers unless otherwise stated. And it was not otherwise stated, so we would say the codomain is all real numbers. If it's otherwise stated, it has to specifically state that it's a different codomain than all real numbers, and if you don't see that, then it has to be all real numbers. Let's look at some others. We're going to find the domain, the range, and the codomain of all four of these graphs. So let's start with the domain. And the bottom of this graph, it almost looks like it's going straight down, but it's really not. You can see that it is slightly angled to the right and slightly angled to the left. So much like the arch-shaped graph up here, this domain is also all real numbers. So I will write that out. I'm not writing out ARN. That's not the abbreviation for all real numbers. The range Again, very much like the previous graph, the range does have certain y values that it does not go past. It's got two of them actually, but they're actually the same y value. Both of these ordered pairs, this is the ordered pair 1, 3. This is the ordered pair -1, 3. Notice both of these ordered pairs have y values of 3, and that's the highest value in the entire graph. So we would say that the range is going to be y is less than or equal to 3. And then the codomain, again, it's not otherwise stated, so the codomain has to be all real numbers. The one to the right, the domain, is also all real numbers. Yes, there are times when the domain is not all real numbers. We will see some here coming up. But in this case, you can definitely see it's going to the left, and it is slightly angled up and to the right, so it is expanding all the way to the left and all the way to the right to all numbers in existence, so the domain is all real numbers. The range. So on this range, it is increasing very quickly upward, so that means it's getting much, much larger and very, very quickly, very, very fast. On the left-hand side, it is leveling out. It actually does not get past the x-axis, and any point along the x-axis has an y value of 0. Every one of these points, if it was touching the x-axis, each one of these points has a y value of 0. So that's like, this is the point 1, 0. This is the point 2, 0. And this is the point 3, 0. But they all have a y value of 0. This particular graph is a little difficult to see, but it actually does not touch the y-axis. So since it does, or excuse me, the x-axis. Since it doesn't touch the x-axis, what we're going to say is that the range is y is greater than 0, but it is not equal to 0. If it actually touched the x-axis, you would say it's equal to 0, but as I had to tell you specifically because it's hard to tell, it actually does not touch the x-axis, which means its y is just greater than 0, not greater than or equal to. And then the codomain, not otherwise stated, the codomain is also all real numbers. Okay, try to do this next one on your own. So pause the video to do the next one on your own, and then you unpause it to find the answer. Okay, so the domain, it's very much like the first example we gave. It's an arch expanding left and right, so it is all real numbers. The range. What is the highest value of y that it reaches? This point right here is the ordered pair 1, 4. So the highest value of y is that 4, and everything else is less than that. So the range is y is less than or equal to 4. And then the codomain, all real numbers. And then the last one. The domain, this one's a straight line. The domain, being a straight line, angling up and to the right and down and to the left, it is moving forever to the right and forever to the left. So yet again, the domain is all real numbers. So what's the range on this one? So the range on this one, it is moving forever upward and also moving forever downward. So in this case, the range is also all real numbers. Ranges could be all real numbers as well. And we already know codomains are all real numbers because, again, it was not otherwise stated.